Okay, in this video we're going over ways to construct using the classical constructions, which only use a straight edge and a compass. If you use a ruler to measure or a protractor to measure, you're technically not doing a classical construction, you're just doing a drawing. And freehand drawing is also never part of a classical geometric construction unless you're just labeling the finished drawing. If we look at the second side of the page, there are some tips on using a compass. So the main thing is you want most of your pressure to be on the point of the compass. You might need a couple of sheets of paper underneath to make sure that the point doesn't slide. And you want to kind of lightly rotate the top of the compass between your fingers and spin it around with just enough pressure on the pencil point part of it to make a tracing on your paper as you, say, try to construct the circle. If you put too much pressure on the pencil point side, it might cause the compass to open up as it goes around and you won't draw a complete circle. So the constructions we're going to work on in this video and we need to be able to do are copying a segment, an angle, bisecting a segment and an angle, perpendiculars to a line from a point on the line and not on the line, perpendicular bisector of a segment, which is really like the midpoint idea, and then construct parallel lines. So if we look at construction 1, we need to copy a segment. So we're going to draw a random length segment, or we're going to construct a random length segment using our straight edge. And then wherever we're going to transfer it to, we need to have another line as sort of a reference line for the transfer. And on this one I'm labeling the point where the segment is going to start at A prime to match the A, but it could just as easily be C, for the starting point. So we take our compass and we measure the distance between A and B, and then we transfer that measurement over to our line where the segment needs to be copied to, and we draw it in. And since I started with A prime for this one, I'm going to call the other point B prime. So that's our copy a segment construction. Our next construction is to copy an angle. So we're going to draw a random angle, and then we also need a side, a side for where we're going to copy the angle to. So we need to draw that and decide where the new vertex is going to be. So again, since our vertex of our angle is D, I'm going to call the place where the vertex is going to transfer D prime. So for this construction, we set our compass to some kind of an arc, and the key is you want to basically have that arc cross both sides of the angle, because what we really need to find are those 2 points that are equidistant from the vertex of the angle. We also transfer that same arc over to where our angle needs to transfer, and we don't change the settings. Then we measure the distance between those 2 points that we constructed on the sides of the angle, and we transfer that measurement over to where our new angle is going to be. And the intersection of the arc, the original arc, and the transfer measurement gives us a point on the side of the angle, and when we draw it in, we will have a copy of our angle. So I called this one C prime, D prime, E prime. For number 3, we want to bisect an angle. So we're going to draw an angle. Then, like the sketch or the construction before, we need to draw an arc. Oh, this is bisect a segment, sorry. So we're going to bisect this segment. So we need to set our compass a little bit more than halfway. A little bit more, a little bit more than half at least, and we strike an arc above and below. And then using the same settings off the other end of the segment, we strike another arc above and below, so those intersect the original ones that we drew. The intersection points of the arcs gives us 2 points. When we connect those 2 points together, it passes through the middle of the segment, and we have bisected the segment. This is also basically the same construction as a perpendicular bisector, because that line is going to be perpendicular to our given line, and it's going to pass through the middle. So that's also going to be perpendicular bisector, which is one of our other constructions. So we could say that M is the midpoint, segment FM congruent to segment MG, and the distance from F to M is equal to the distance from M to G. We've made congruent segments because M is the bisector. So let's look at construction 4. Construction 4, we're going to bisect the angle. So we need to draw an angle. I think I'll draw an obtuse angle this time. And then we need to strike an arc that crosses both sides of the angle. And what that does is that gives us a couple of points that are both equidistant from the vertex. Then we're going to use those points and strike two arcs in the center of the angle. So I'm finding the 2 points that are equidistant by striking that arc. You don't have to do the arc all the way across, but the important thing is that they both cross. I make my compass a little bit larger, and I use one of the points to strike an arc in the middle, and the other point to strike the same size arc in the middle. Where those two arcs cross each other gives me a point. When I connect that point to the vertex, I will have bisected the angle, or cut the angle in half. So I called that point K. So we have angle HIK is congruent to angle JIK. Also, the measure of HIK is equal to the measure of JIK. Or we could say that the measure of HIK is 1/2 the measure of HIJ, and so on, since we've divided the angle into two parts. So we'll look at our next construction, number 5. And number 5 is construct a perpendicular to a given line from a point not on the line, or from a point on the line, I think. So we're going to draw a segment. We're going to put a point on the segment. Now what we need to do is use our compass to find 2 points equidistant on either side of that point that I have labeled as L. So I'm finding the point on the left, and then keeping the radius the same, finding the point on the right. So those 2 points are both equidistant from L. And then I use those 2 points. I have to make my compass a little bit larger than halfway now, a little bit bigger. So I stretched out a little bit. And all I really need to do is strike an arc above. And from the other side, I also strike another arc above. Where those two arcs cross each other, if I draw a line between that intersection and my point L, we will have a perpendicular line that goes through point L. So we've constructed a perpendicular to the line from a point on the line. And I marked it with a little square to show that that's a perpendicular line and it makes a right angle. That's our mark for a right angle. Our next construction, construct a perpendicular to a given line from a point that's not on the line. So I'm going to construct a segment, and I'm going to put a point up above it. And then I'm going to use that point that I have labeled K, and I'm going to strike 2 arcs on the line. And what that's really doing is finding 2 points that are equidistant from K on that line that we want to draw the perpendicular to. So then I'm going to use those 2 points, make my compass a little bit larger, and I'm going to strike an arc down below. And from the other point with the same radius, I'm going to also strike another arc down below. Where those 2 arcs cross each other gives me the intersection point, and I connect that to my point K, and that will give me the perpendicular to the line. I'll call it point L, bring my straight edge up, draw the line, and I have a set of, really 4 right angles there, because that line's perpendicular, and then all those angles are going to be right angles. So this was to construct a perpendicular from a point that's not on the line to the line. Okay, let's look at our next construction. Our next construction is to, I think, bisect a segment. Oh, perpendicular bisector of a segment. So that's really the same thing as the finding the midpoint that we did for the bisect a segment, except now we're more focused on the actual line that we draw to find where that midpoint would have been. So this is really the same construction. I'm going to draw a random segment length. Off each end, I need to set my compass a little bit more than half way. So it needs to be a little bit more than half the distance from M to N. And I strike an arc on one side of the segment, and then keeping the same radius, I do the same arc down below. We could also do half circles. It's just neater if you just do the arc part. And then from the other end, I keep the compass radius the same. I do the same thing from the other end of the segment, an arc on either side. Where those two sets of arcs cross each other gives me those intersection points. When I connect those together, that will give me a line that is perpendicular to that segment. So that line that's off, or that point that's off the MN line, or MN segment, doesn't have to be in the middle, but this is the construction that will guarantee that we have a perpendicular line to the segment through wherever that point happens to be. So we get, so if I use the script notation, I have my original line was M, the one I constructed was L. We could say that line L is perpendicular to line M. And our last construction, construct a line parallel to a given line through a point not on the line. This is really doing 2 perpendiculars. There's going to be a perpendicular from a point on the line, and also a perpendicular from a point that's not on the line. So both of these combined together give us parallels. If we take a line and we rotate it 90 degrees, we have a perpendicular. If we rotate it another 90 degrees again in the same direction, we'll have a line that's actually parallel, because the two 90s actually make 180. So that's like a half circle rotation. So there's my line and my point that my parallel line needs to go through. So the first step is to construct a perpendicular from that point to the line. So that's like the construction we did before. I set my compass at some thing that's going to hit the line, some radius going to hit the line, and I strike an arc on either side. And I strike the same arc down below from either side. And when I connect the original point with the intersection of those two arcs, I'm going to have my perpendicular line that goes to that point. So I'm going to sketch that, or trace that in using my straight edge. And now the next construction, I'm going to use that point, and I'm going to construct a perpendicular to the line that I just drew through that point, and those two perpendiculars will give me the parallel line. So the construction for this is to find a point equidistant on either side. So I'm keeping my compass measurement the same, doing a point on either side. And then I use those 2 points that I just constructed, and I strike an arc from one point, and I strike another arc from the other point. We don't really have to do one on both sides, just as long as because we're going to hook the original point up with the intersection of those two arcs. And then I'm going to sketch the line. So this is the construction that goes with construct a parallel to a line through a point that's not on the line. And we're done.